Okay, now we're going to get into an aspect of ionic compounds that you're probably not at all familiar with. Not that you're really all that familiar with ionic compounds to begin with, but you had a little bit of experience with it, sodium chloride, for example, even though you didn't know it's an ionic compound. We're going to get into what we call hydrates. Now, there's a video I want you to watch before you go any farther, if you've not done it yet. There's a hydrate video I've attached. I want you to watch it all the way up to the 4-minute and 28-second mark. All right? It explains what hydrates are, and it shows you what they look like when the anhydrate becomes hydrated. That'll make sense after you watch the video. Stop it now if you haven't done it, and then come back, and then we'll continue from here. Okay. So let's take a look at copper, or CuSO4.5H2O. Now, they talked about this in the video, and this is one that we have a lab that we actually do. When we do labs, which I don't know if we're able to do one this year, but I hope we can, this is one I would like to do, so you can get a chance to see how this all works. This is an ionic compound. How do we know it's an ionic compound? You got the metal, or positive ion right here. The exception, of course, is the NH4, which is not a metal, but it is a positive ion, and it goes right there. But regardless, this is an ionic compound. And as the guy explained there, when crystals are formed in what they call a solution, a mixture with water, and they evaporate off the water to get the ionic compound back, or what they call the anhydrate. Anhydrate means without water, so it's a crystal without water, anhydrate. Well, when that happens, the water gets trapped in that process. And so the crystal looks different. It's still this, but it's got 5 moles of water trapped in the crystal for every 1 mole of copper sulfate. Okay? So what we want to do is name this compound. Okay? Now, we're going to follow the same rules we did in the previous lessons. First, is this a transition metal? Well, if you take a look at copper on the periodic chart, it's in that middle 10 elements, and yes, indeed, it is a transition metal. So we're going to have copper. Then we come to the SO4. Now, remember, an ionic compound has a group of positive ions and a group of negative ions. It doesn't split up into different ones. This is our positive. This whole conglomeration, SO4, is called a polyatomic ion. And the polyatomic ion, and there's a polyatomic ion chart I've attached for this lesson. You find SO4 on there, and SO4 is called sulfate. So that's sulfate. Okay? So, put sulfate right there. And we also know on that chart that the charge of sulfate is -2. Okay? So, if this is -2, then what does copper have to be in order for the 2 of them to add up to 0? Yeah, +2. So we put a Roman numeral 2 there. And then I'll pretend like I didn't do that, because that should not be in the name. But it helps us get to that point right there. The next part is the dot 5H2O. Now, the dot is basically saying it's really not part of the compound, it's just kind of there. It doesn't mean a time sign, it's just kind of like a symbol saying it's not being counted as part of the compound per se. And we'll get into an exception of that in the next lesson. So there are prefixes. This is called a hydrate. Water is, if somebody is dehydrated, it means without water. Well, hydrate means water. And this is, has a numerical value to it as the number mole per mole of crystal. And that has a name for it. So, in the script, which you should be looking at, we have prefixes for both first 10 numbers. Now, 1, it either is mono or just none at all. So if I don't give you a prefix, you know that has a 1 on it. 2 is di, 3 is tri, 4 is tetra. If you ever played the game Tetris, you know that every block has how many parts to it, or how many blocks in it? 4. 4 is Russian for 4 is Tetris, so that's where they get the name tetra from. 5 penta. Now this goes to all your polygons. If you remember your geometry days in middle school, you had pentagons and hexagons and octagons and all that. Same thing here. Penta 5, hexa 6, hepta is 7. Many of you get familiar with that one. Octa is 8, and nona or nana is 9. I've heard both pronunciations. And deca is 10. Now there's actually more than 10, but it's very rare. And generally the larger it gets, the more rare it becomes. So use this chart to come up with names in your practice problems. Okay? So that means then that we have 5, the prefix for 5 is penta, so this becomes pentahydrate. Note, the dot does not come down here. Do not put a dot in the name. If you do, I will say, no, you're not going to do that. That's not, as the British say, that's not the cricket. Okay? First example in there, we have neodymium CO43.3H2O. Same thing. Neodymium, is that a transition metal? Well, it's not in the middle 10, but it is in the bottom 14, so that makes it technically a transition metal. Actually, we call the ones in the bottom 2 inner transition metals, but they are part of the transition metals. So this is a transition metal. So neodymium. I really want to name my first child neodymium, because I thought it was just a cool name. I don't think my wife has stopped slapping me since. Every time I walk the door, neodymium my butt, she says. Just kidding. This element right here, or this polyatomic ion right here, is right there. Perchlorate, CO4 charge, -1. Okay? So this is going to be perchlorate. Now again, the charge for that is -1. Neodymium, we know, oops, I forgot to put the parentheses there because that's the whole point of that. Put parentheses right there, and then perchlorate. Now that would be a main group metal, we wouldn't put the parentheses in there. The main group being first 6 or 2 last 6 columns in the periodic table. We have 3 perchlorate, so multiply that by 3. This is -3. Therefore, this must be +3. Add that up to 0. So there is our name of our compound there. Neodymium 3 perchlorate. This kind of rolls off the tongue, doesn't it?